Okay, edited, new, first video for page 1 of FTC/accumulator functions. So, hopefully fixing the area or error that Julia pointed out. Anyway, we've got a function, g of x, that is defined as the integral from -6 to some value x of f of t dt. Weird little things to notice is the function f of t. It's a function of t, so that's not really the x-axis, it's the t-axis. And that function that's graphed is of f, not of g. So you have a function that's defined off the integral of another function, so it's a little strange and weird at first, but it'll take some getting used to and we'll be kind of okay. So let's basically just do it. But in general, that letter up top, x, and that letter there, t, kind of need to be the same. Or sorry, need to be different. If they're the same, it's sort of okay, but it's like actually kind of weird and worthless if that's the case. So let's just run through this thing. So when it asks you to do g of -6, it is effectively just asking you to do the integral from -6 to -6 of the graph of the function they gave you. So you basically just want to find the area between the curve and the x-axis when you start at -6 and go to -6, which is kind of strange because that is no area. There is no space from -6 to -6, so that's just a 0. B asks you to do g of -4. So you effectively just want to integrate this function from -6 to -4 of f of t dt. So what you're basically going to do is find the area of this green triangle here, and just that's it. So that triangle has a base of 2 and a height of 4, so this should be 1/2 of 2 times 4, which should just get you 4. And then on part C, C is asking you to do g of -2. So that would be you integrating from -6 to -2 of f of t dt. So the reason it's basically called an accumulator function is you could act like the space from -6 to -2 is just start over. It's this one big triangle with a base of 4 and a height of 4. But -6 to -4, we already are talking about this much area, which we already know is 4, and then we accumulate more area when we go from -4 to -2. So we're going to accumulate a second triangle, which has a base of 2 and a height of 4, so that's going to be plus an extra 1/2 of 2 by 4, which is another 4, so that should wind up being 8. So far, here's what we've got. G of -6 is 0, g of -4 is 4, and g of -2 is 8. Now I ask you to find 3 more spots, so let's find those 3 more spots. I ask you to find g of -1, g of 4, and g of 8. Now really we could find a bunch of other spaces. We could find g of 2 and g of 3 and g of 4 and g of 5. This thing is made up of just a bunch of line segments, so it should be kind of doable. We're always making triangles and rectangles and other things like that. So g of -1 is telling you to integrate the function from -6 to -1 f of t dt. So in that true kind of accumulator function, we already know if we go from -6 to -2 that we've accumulated 8 units worth of area. And we're just going to accumulate this extra upside down triangle. So this guy is 3 by 3, but it's down, so that's actually negative. So this should be 8 minus 1/2 of 3 by 3. So that should be 8 minus 4.5, which is 3.5. Positive 3.5. So g of 1 is 3.5. Then when we go to do g of 4, we already know that if we went from -6 to 1, we would have gotten 3.5. And then if we just keep going, we're going to accumulate this extra upside down triangle, so this should be 3.5 minus 1/2 of 3 by 3. you don't really need to assign the base positive or the height positive and the base negative and the height negative. Just when it's supposed to be positive, make it positive, and when it's supposed to be negative, make it negative. So this winds up being 3.5 minus 4.5, so g of 4 winds up being negative 1. And then finally, g of 8, you can just accumulate a bunch of additional area. I'd like to actually sneak in here real fast and find a g of 5, even though it didn't ask you for this. But g of 5, you're going to accumulate one extra triangle here. So g of 5 would be you integrating from -6 to 5 f of t dt, which would be the -1 you've accumulated all the way up until you got to 4, plus an extra rectangle that is 1 by 4. So that should be -1 plus half of 1 times 4. That's plus an extra 2, so that should just be 1. So even though it didn't ask you for g of 5, that winds up being 1. And g of 8 is that 1 unit we got, plus an extra big giant rectangle that I think is 3 by 4. So that's plus an extra 12 for that rectangle. So that should be 13. So officially g of 8 winds up being 13. So now let's talk all these weird little values and these other follow-up questions that kind of get to the place that we want to get to. So we can answer those increasing, decreasing, max, min questions right away, or we can try to draw the graph first. It doesn't truly matter. So let's answer some of those questions. So in terms of increasing and decreasing, let's just think about it logically. We start out at 0 because we have no area at the beginning. And then as x increases, we start accumulating more and more and more area. So we're increasing. Then we start increasing, we keep increasing until we get to -4. So, because we keep accumulating area. So we're increasing from -6 until, after we get to 4, we keep accumulating more area. So until we get to -2, we've been accumulating more and more rectangles the whole time. So we're increasing. But once we get to -4 or -2, we start accumulating rectangles. They're just upside down. So that's going to make us decrease and shrink until we get to 4. So we're going to decrease from -2 to 4. And then after we hit 4, we're going to increase the whole time because we keep accumulating taller and taller and taller rectangles, which is going to make our area bigger and bigger and bigger. So that should be 4 to 8 is where we stop. And since we increase from -6 to -2, we reach a max when we start decreasing. So your max is going to occur at x equals -2, and your min is going to occur at x equals 4, because that's when we end our decrease and start our increase a second time. Might be easier to see that on the little sketch, so let's make the little sketch. So -6 made 0, -4 made 4, -2 made 8, and this is 4, 5, 6, 7, 8, -2 made 8, 1 made 3.5, 4 made -1, 5 made +1. It's not on your chart, but probably good to put it on there anyway. And 8 makes 13, which kind of runs off our page a little bit. Now, we could just lazily kind of play connect the dots and draw something that goes up and then goes down and then goes up, but we can actually do better than that. So at least initially, when we accumulate rectangles, As we move to the right, our rectangles get taller and taller and taller and taller and tallest. Eventually at -4, that is the tallest rectangle we ever accumulate. So the areas we gain, each little step we move over, we gain more and more area, which means we go up, but we go up faster, aka concave up. And then we start to accumulate even more rectangles. They just start to get shorter. So since the rectangle, we're accumulating positive area, we're growing, but since those rectangles are getting shorter and shorter and shorter as you progress, you're increasing but at a slower rate, aka concave down. And then we start to accumulate upside down rectangles, which is why we decrease. And those rectangles get taller and taller and taller and taller, which means our rectangles that we're accumulating are decreasing our area faster and faster and faster and faster, because each one is taller in the negative direction than the one that came before it, which causes us to decrease rapidly. Then we start to accumulate these rectangles, which are still negative because they're upside down, so we start to get smaller and smaller and smaller, but like slower and slower and slower, because each one was less negative than the one that came before it, so that causes us to decrease just slower. Then we get to this last little region, which makes us increase because it's positive, but the initial rectangle is short, and then they start to get steep really fast. So we sort of have to increase really, really fast. But after we hit 5, literally every single rectangle has a height of 4. So each subsequent move increases the area by the exact same amount, which causes us to increase in kind of a linear fashion, so your curve winds up looking like this. So here are the big takeaways we're hopefully getting from this particular accumulator function task. 1, this function is increasing. You can do it from there, but the big takeaway is, when is the g function increasing? G is increasing when f is positive. And g is decreasing when f is negative. So, increasing when something is positive, decreasing when something is negative. Crazy. It's like there might be some connection between these functions, as if there are other functions that are positive and it leads to something else being increasing, or negative and leading to something else being decreasing. Cough, 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 the derivative. The other thing we can tell is when is this thing concave up and concave down? It's concave up when f is increasing, and it's concave down whenever f is decreasing. Those are the big takeaways. So g is concave up when f is increasing, and g is concave down when f is decreasing, which also links some function types we know, hopefully, cough, 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 derivative / second derivative. So hopefully this fixes the minor little negative sign error I made. Sorry for people who watch this video. Thanks, Julia, for catching the mistake. Soon to be uploaded, the fixed and better video.